right, so today we're going to look at lesson 4-7, piecewise functions. So we're going to evaluate them, we're going to write and graph them, and then we're going to write some step functions. Really, what a piecewise function is just two or more equations. So we're only using a piece of them. So if we take a look here, my function x minus 2 is this line where x is less than or equal to 0. Because it's on the x-axis, so x is 0 here. And then x plus 1, or 2x plus 1, which is this one, if x is greater than 0. So again, it's on the x-axis, so here my x is 0. So we're comparing it to 0 here because it's on the x-axis. On the x-axis. Now, if you recall, when we were doing inequalities before, we have an open circle if it's less than or greater than, and a closed circle if it's less than or equal to or greater than or equal to. So let's take a look at how to evaluate some of these functions. So we've got this function, which is the same one as above, and I want to evaluate it when x equals -1. So when does it meet the criteria? So we always want to use the function that meets the criteria. Okay, so if I look, x is equal to -1. So which one of that does it work? Well, let's see. -1 is less than or equal to 0, which means we're going to use x minus 2. So we should have -1 minus 2. So that, therefore, gives me -3. I was jumping ahead a little bit there. Now, when x equals 1, well, 1 is greater than 0, which means we're going to use the 2x plus 1. So I'm replacing it as an x with 1. So I have 2 times 1 plus 1. 2 times 1 is 2 plus 1 is 3. So I've got 2 times 1 is 2 plus 1 is 3. Nice. All right. So how would we graph this? And then let's describe the domain and range. So if we have the same graph here, so if we have -x plus 2, well, how would I graph that? Well, first of all, my x is less than or equal to 0. So if it's less than or equal to 0, that means it's a closed circle on my y-intercept. So that's this right here. Now, I have a negative slope, but I want all values where x is less than. So if I were to have a line like this is greater than 0, I want less than 0. So my line's actually going this way. And if I check, that is a negative slope. So I've got my line here. I want to go ahead and get a protractor and draw the line right here. So this is y equals -x plus 2. So this is the first thing I want to do. The second thing I want to do is graph 2x. If x is greater than 0. So again, x is 0. Now my slope is 2. That means I'm going to go up 2 over 1, up 2 over 1. So now this here is my graph of y equals 2x. Now, we do have those descriptors. That's why I don't have anything over here or over here for this graph. Now, let's talk about the domain. So, my domain here is all real numbers, okay? Because if I had x is 2, it's on this graph. If I had x is -2, it's on this graph. So I'm talking about both graphs here, not just one. So next, let's talk about the range. in the range is the y value. Well, what is my minimum y value here? Well, it's this one right here. So my range is y is greater than 0, because it can't be 0, but it can be any number greater than. Now, how could I go the opposite direction? So given the graph, what would my piecewise functions be? When we started off, we have y equals, and these are brackets. So I'm going to talk about this first one. Well, let's see. I'm going to kind of go a little bit backwards here. So I know I'm comparing x to 0. So I have x, and it's all values less than, but it includes this point. So it's less than or equal to 0. Okay. Now my y-intercept here is -2, and then my slope down 1 over 1, down 1 over 1 is -x. So my equation of the line is -x minus 2 with the parameter x is less than or equal to 0. Now if I look at this one, again, I'm comparing x to 0. And let's see, it is an open circle and it's all values greater than 0. So where's my equation of the line? Well, my y-intercept is -3 and my slope is up 2 over 1, up 2 over 1. So I have 2x minus 3. Now, we have also different types of piecewise functions. And this one is called a step function because it looks like there's steps. It's amazing how all that works. So if you notice, there's a whole bunch of different parameters here. So a step function is just defined by a constant value over each part of the domain and contains a series of line segments. So you've got a line segment, line segment, line segment. So if I look at this one, 0 is greater than or equal to x, but less than 2, so it doesn't count. So if it were to be 2, so we've got, or 3, we're right here, 4, 5, 6, and 7. So how would I graph one of these buggers? So you rent a bicycle for 4 days. The bike store charges $20 for the first day and $15 for each additional day. Write and graph a step function that represents the relationship between the number of x days and your total cost. So if you rent a bike for a day and a half, that's still considered 2 days. You're not being charged by the hour or the minute, you're being charged by the day. So we've got f of x equals, I'm going to make a big bracket here. It's not the prettiest, but so it's the first day is $20. And if I rent that bike and use it for 30 seconds, it's $20. If I use it for 23 hours and 59 minutes, it's $20. So 0 is greater than x, or x is greater than 0, and less than or equal to 1. Now it increases 15 each additional day. So that's 35, 50, 65. So on day 2, it's $35 if it's greater than 1, but less than or equal to 2. So it's $50. Oh, I forgot my commas. Put your commas in. So if x is greater than 2, but less than or equal to 3, and it's 65 if x is greater than 3, but less than or equal to 4. All right, so what does it look like to graph this? So I've got all this information. So I only need the first quadrant. And this is going to be number of days. And this is going to be my total cost in dollars. And of course I want a title, which is my bicycle rental. Okay, so since this is number of days, I've got 1, 2, 3, 4, 5. And then don't forget my arrows. This is my X. This is my Y. So I'm probably going to want to start at 20. So I've got 20, 35, 50, 65. So now what does this look like? So open-ended at 0, closed at 1, open-ended at 35 right here at 0, or I'm sorry, at 1, closed at 2, so 50, notice it's obvious that these are open. So I'm all set with a beautiful graph.